This is 7-2A in Advanced Algebra 2. Today we're solving for x, but x is up in the exponent. And we're really trying to prep you for logarithms, right? That's what logarithms were invented for, is how do you solve for x when x is up in the exponent? But today we will do a little trick, right? We will try to get the bases to be the same. So here's our situation. We're going to examine the two bases. If they're not the same, all of our problems today will be possible to rewrite them with the same base. Then we'll set the exponents equal to each other, and then we'll check our answer. So check it out. Over here on the left side, isn't this got a base of 4? Over here on the right side, doesn't this have a base of 2? Not the same base. Is it possible to rewrite them as the same base? Obviously, base 2 is base 2. Can you change 4 into something base 2? Like, you know what's so great about 4? It's a perfect square, correct? So isn't that really 2 squared? Isn't that what 4 really is, correct? So write it like this. We're going to say that's really 2 squared, and it's 2 the x minus 1 power. And I'm going to put that x minus 1 in parentheses. All I did was change this 4 to be a 2 squared. You cool with me on that? And that will equal 2 to the x plus 5. Still. Now do you see that they are both written as base 2? We'll use some Algebra 1 concepts here. Don't we have a power to another power right here? What can we do with the exponents? Do we add them or do we multiply them when you have power to a power? Multiply them. So isn't this really 2 to that? You have to distribute this 2 through those parentheses, correct? Because it's 2 times the quantity of x minus 1. So what would that exponent be? 2x minus 2. Is everyone cool with that? That should equal 2 to the x plus 5. And now do you see that's really clean, and they're both base 2s. If they both have the same base of 2, and you want them to be equal, take a wild guess what has to be true about these two expressions right there. They have to be equal to each other also, right? So now we can drop the bases, and we can just say, hey man, I want to solve this. 2x minus 2 equals x plus 5. Because they are rewritten with the same base, now we must get the exponents to be the same thing for them to be equivalent. So solve for x. So x minus 2 equals 5, x equals 7. Correct? Now we get to do the fun part. Check it. Let's see if it works. So we'll do the same old.
Whoa, magic of editing right here, guys. When this video was originally recorded, we used to have students do a lot of work by checking their answers and showing the written work for checking your answers. It's a good idea to check your answers, but we no longer require the written work. So what you're going to see in the next 8 problems is a bunch of jump cuts after the problem is done. Again, the magic of editing, jump cut right there. New vocab word for you. So when you see it jump from next problem to the other, you're going to see all this work show up on the other side about checking the answer. Don't worry about showing that work. We don't need that anymore. So the magic of editing will show you the work that you need to do. Just do this work. Thanks.
Possible to rewrite 8 as base 2. 8 is not a perfect square, but it is a what? It's a perfect cube, correct? So this is still 2 to the x, and what is 8 if we change it into a perfect cube? 2 cubed, right? And then you got to realize that that thing is still being cubed, right? The 8 became the red 2 cubed, and the 8 had to get cubed. That's where the green 3 came from. You with me on that? So over here, power to a power, 2 to the x equals what? 2 to the 9th. And then since we have the same base, it's quite obvious now for these to be equal, x has to be how much? X has to equal 9. And then smaller base, can you turn 9 into a base 3? What is it? It's really 3 squared. Don't try to be that hero and do all that stuff in your head. Rewrite it like this. You know, save yourself the mistake that'll happen. As 3 squared to the 2x minus 1. I like to put that 2x minus 1 in parentheses. That helps me realize I got to distribute when I do the power to a power stuff. So that would be 3 to the 6x minus 2, right? Is that right? Sorry, my bad. I was looking at something else. Thank you. 4x minus 2. Thank you. And that should equal 3 to the 6x. They are both of the same base 3 now, right? So let's set the exponents equal to each other. Yeah. Yeah. And then subtracting 4x. Come on, 10. Work for me. X equal 1. Is that what you got? What is wrong with me? I got spring fever, apparently. So x equals negative 1, right? All right, well, let's go check it. Can you have... Cool. Number 4. It is totally possible to probably write both of those as base 2. The question is, can we write them both as base 4? Is 64 a perfect fourth? So why don't we try to just write them as base 4? It doesn't matter if you write them both as base 2 or both as base 4. It'll still get you the same answer, but let's do less work if possible. What is 64 rewritten as base 4? 4 to the 3rd, right, or cubed? Cool with that? And see, now I don't have to do any of that crazy distribution or any of that stuff. I have them both as base 4, so 2n minus 1 should equal 3. Try 5 with PAL. Try to rewrite them as the same base. So, video land people, hopefully you tried it and got to the point where you can rewrite them both as base 5 and get this guy. Ah! Here's the tricky part of this stuff. This has a base 3, correct? This is a fraction. All that fraction means is, what if we had a negative exponent? What will the negative exponent do to that 1/9? It would reciprocate it, correct, to turn it into 9. So just think about this denominator for a second. Is it possible to rewrite the 9 as base 3? What would it be? 3 to the 2nd, correct? But if I wanted to flip over, I need to make it not 3 to the 2nd, but 3 to the negative 2nd. With me? So let's rewrite it. 3 to the 2x minus 1, that didn't change. I know this 9 can be rewritten as a base 3 if I make it squared, but to flip it over, I needed to make that a negative 2. Does that make sense to you? The negative exponent turned that 1/9 into a 9. Cool with that? All right, so now they're both base 3s. 2x minus 1 equals negative 2. Solve for x. Get x equals negative 1/2. Right? Do you see a fraction in this situation? Yep. Let's look at the smaller of these. There's a 16 and an 8. Can you write 16 as base 8? Like 8 to what power equals 16? It doesn't work, right? So that means we're going to have to change both bases. Let's think about their multiples. Can you write them both as base 4? 4 to some power equals 8. Is that possible? Nope. How about base 2? Can we write them both as base 2? 2 to what power equals 8? So 2 cubed is really that 8. And there's your x minus 2. Again, we're going to think of this right side as if it was a 16, right? But since it's a fraction, once we figure it out, we'll make that exponent negative. Cool? 2 to what power equals 16? So I really wanted us 2 to the 4th, but that 4 must be negative to get that puppy to reciprocate. Rock and roll. And then, of course, there's nothing left over there, so we will just leave her like so. And now we will clean it up. That's 2 to the 3x minus 6. What am I doing? I got spring fever or something here. Get them both as base 2s first, right? Don't cheat on me and try to go straight to the exponents. Now they're both base 2s. set the exponents equal to each other. Okay. Is that right?
All right, now we're going to solve some more exponential equations, but these bases cannot be rewritten with the same base. So like 3 and 15. 15 is not a power of 3. So we've got a real simple idea. This is what logarithms were invented for, was when you can't rewrite them with the same base, we're going to log both sides. So what we do to one side, we can do to the other. Do you see how I've totally just logged both sides? And I use the common log. So the reason why we can do that is because we can now use the properties of exponents that we learned, that this exponent gets to come down in front. So you get x times the log of 3 equals the log of 15. Sorry that my pen dragged right there. And to get x all by itself, now we could just divide by the log of 3. So x equals the log of 15 divided by the log of 3. And this is the exact answer. And if you're thinking that that might simplify to be like the log of 5 because you see the 15 divided by 3, it doesn't quite work that way. So let's get out of that graph our answer. We've got the log of 15, and remember how that log automatically starts a parenthesis, so make sure you close that parenthesis, divided by the log of 3. And hit equals, and they say round to the nearest 10,000. That's 4 decimal places. So 1, 2, 3, 4, and so we have to look to the 5th decimal place. Let me make it large so we can see what's going on here. We got to move to the 5th decimal place, and that's going to round us up. So we're going to call this about 2.4650. Yes, we need to put the 0 because they say round to the nearest 10,000. So we'll put the 4th decimal place even though he's a 0. So that's kind of neat. We log both sides. So let's do that again. I can't rewrite this with the same base. The x is up in the exponent though, so that's why I'm going to try that technique. But I'm going to log both sides. And instead of writing 2 to the x, isn't the whole idea to get that x to come down in front? So Mr. Exponent automatically comes down in front when we log both sides. So we'll try to kill 2 birds with 1 stone there and see that x equals the log of 5 divided by the log of 2, and we'll go punching that in. Log of 5, close it, divided by the log of 2, and we'll round it to 4 decimal places. So x is about 2.3219. So you look to that 5th decimal place, and since he's less than 5, we will not round this up. So we'll get this old boy. And why don't you pause the video and try this one. 4 is not a power of 19, so we're going to log both sides. Pause the video, try to get that done. So remember, when we log both sides, the exponent comes down in front, then you divide by the log of 4, and because we're rounding to 4 decimal places, 2.1240, because the 5th guy's 5 or larger. So those are plain Janers right there. Like the exponent is just an x. As you can see here, we get a little more challenging, but still 8 has not some sort of power of 3, so I want to log both sides. And when I do that, the exponent's going to come down in front, but the trick is we're going to put that exponent in parentheses when we bring him down in front. So you can see that the exponent was x plus 1, just kind of have him in parentheses, and he gets to come down in front. And there's a couple ways to solve this, you know. What we're going to do is, I'm going to do it this way, is I'm going to get rid of this times log of 3 by first dividing. You know, you could distribute that, but that truthfully makes it a little messier. Sometimes you have to do that. I've gotten rid of those problems where you have to do that. So we're going to divide both sides by the log of 3, so that's going to leave your x plus 1, who was in parentheses and now doesn't really need to be in parentheses, divided by the log of 8, equals the log of 8 divided by the log of 3. And to get our exact answer, to solve for x, all we got left is to subtract 1, so we're going to leave this number the way it is, and then just have a minus 1 over it. So it's now we got to do this to the nearest 4 decimal place, to the nearest 10,000. So yikes, sorry. We will punch this dude in. Let's get you out of the way a little bit there, buddy. It's going to be the log of 8, close it, divided by the log of 3, close it. I personally like to hit equals there, but I'm not going to round it off. I'm going to take away 1, and this is the answer that I'm looking for. We'll round him to 4 decimal places, so 0.8928 is what we'll roll in that scenario. So we got her here. Let's try that again. X is up in the exponent, so I need to either rewrite with the same base or log both sides. Since 120 is not a power of 5 because it goes 5, 25, 125, we're going to log both sides. Mr. Exponent comes down in front when we do that, so got him here, and I'll have the log of 5 equals a log of 120. So again, I think this move's going to work for us this time around. We're going to get rid of the times log of 5 by dividing by the log of 5 first. So that's going to leave you the 4x minus 2 equals the log of 120 over the log of 5. And then we got to get rid of this minus 2 by adding 2, but you'll see that we still have 4x over here instead of just x this time, but I'll show you how we'll deal with it. We just got to do all this cool writing of stuff down. But I'm going to start punching this in as of now. Well, let me small this up. Oh, buddy. Sorry for that. Let me punch this in now. Log of 120, close that argument, divided by the log of 5, close that argument. I'm going to hit equals. I'm going to add 2 to it. And then in this work, like I don't want to write it all over 4 because it's not proper, but we know that to get x by itself, we just got to divide by 4 in that case. So x is about, we'll round that to 4 decimal places, 1, 2, 3, 4, the fifth guy's 5 or larger, so that'll be a 7. 1.2437. Let's double check that. 1.2437. Yes. So we're just logging both sides because we can't rewrite them as the same base. Let's do one last one of those. So when we log, the exponents come down in front. Please put them in parentheses to keep that proper right there, mate. And then we'll get the log of 120. And we can get rid of that times log of 3 by saying the exponent, which now doesn't have anything multiplied by it, so you can get rid of the parentheses. Log of 120 over the log of 3, we'll get 2x by itself. It's a lot of writing here. And we'll add 5. This is how we got 2x by itself. And then it's time to punch this homeboy in. So we'll do the log of 120, close the argument, divided by log of 3, close the argument, hit equals, add 5 to it, oops, I hit times, add 5 to it, boom, and then to get x by itself, we just got to divide by 2. So x is about, and we'll round that to the 4 decimal places, 1, 2, 3, 4, 5, so that's going to come up to be a 9. X is about 4.6789. Hey, it's like the point is a 5. 4, 5, 6, 7, 8, 9. Ha ha ha. Funny.
Let's try the next problem. First, you see if you can rewrite them at the same base. What base would you choose to get this 64 basically and this 16 as the same base? It has been suggested that we try base 4. 4 to the third is 64, but since I need to flip this puppy over, I really want 4 to the negative third equals x minus, or to the x minus 2. And 4 to what power is really 16 squared? And that'd be 3x plus 1. Yes, sir, Bob? All right. Solve for x. Yeah. Welcome. How'd you feel about them, though? Right? 4 was enough, don't you think? I mean, it's not like it's hard. It's just they're nasty. And parentheses is the hardest part about it. Change of base formula. This is something you really want. All kinds of college algebra questions about change of base formula. So looking through the change of base formula, they say, well, if you want to figure out what this is, why is this different than what we did on the first group of problems? Why can't we just punch this into our calculator? It's now base 10, right? The only thing that your calculator will do is base 10 logarithm. Well, this is a base 3 logarithm. Well, this says the log of the argument divided by the log of the base is what that will be. But you know me. I'm a geometry guy. We prove stuff in geometry. So let me prove to you why this works. It might make perfect sense to you. Y'all cool with me doing that? Rewrite it exponentially for a second. You don't have to rewrite this. Just watch me. What would it be rewritten exponentially? 3 to the x equals 16, correct? Let's see if we solve for x now. Isn't it an exponential situation? First one's base 3, second one's base 16. Can you rewrite it as base 3s? Is that possible? So let's log both sides. Wouldn't it become to x log of 3 equals log of 16, correct? And how would you solve for x? And doesn't x equal log of the argument over log of the base? Isn't that a situation? Right? Isn't that what happens? So that's what this happens every single time. If we've made you rewrite it exponentially, then log both sides. It's always the log of the argument divided by the log of the base. So let's punch that in. Cancel. I want an eraser is what I want. Let's punch it in. Let me get to my calculator screen. I want log of what divided by log of what? Log of 16 divided by log of 3. And you tell me, is this going to give me the right answer? Let me make it big for you. Is that going to give me the right answer? Nope. What did I forget to do? So log of 16 closed divided by log of 3 closed. Boom. About 2 point, what does it say to round to? 10,000. So about 2 point what? Tell me. 5237. What do I need in front of it? Approximate. Try this bad boy. Log base 200 divided by log base 12. I keep saying base. It's not base. Log of 200 divided by log of 12. Sorry for my stupidity. About what? Sorry, and I wanted you to write this down. So on the homework, let's do the next one the way we'll do it on the homework. I want an exact answer, and I want an approximate answer. So see how I wrote this? Let's do that on the next one. Exact answer is log of 5 to the 4th. If you want to punch that in first, you can. What is 5 to the 4th power? So log of 625 over log of 6. That's what I want you to have. And then tell me what that is approximately. It's about 3.5930. Nice. Yes, sir, Bob? And then the next one. Log of the argument. I'm going to write it as 39 to the 1/3 over log of the base, log 4. Cool? If you are a person who really wants to put that in front, you can. You just got to type it in correctly. I'm not going to put it in front. I'm just going to type what I see. But here's the problem. Isn't the entire argument this? Right? That has to go in parentheses. So punch it in and see what you get. I hope you get 0.8809. 0.8809. Let's see. Log of, what is it, 39? Let me get rid of this. Go away. Go away. Log of 39 to the 1 divided by 3 power divided by log of 4. Look at all the parentheses I had up top. Let me make it a larger view for you now.
And then to finish this guy out, we're just going to refresh the memories from what we did last time, solving log equations. So the questions that you're asking yourself is, does every term have a log with it? In this guy, that's yes. So that means you can drop the logs and set the arguments equal to each other. And now since this is quadratic, we're going to get them equal to 0. X squared minus 6x plus 8 equals 0. And we'll do a little factoring. Two numbers that multiply together to be 8, add together to be negative 6. Looks like negative 2 and negative 4. So this can factor to be x minus 2 times x minus 4 equals 0, to where x could possibly equal 2 or 4 in this case. And you may have noticed that my voice got a little funny in this situation because I was going back to check these and I did all this work for nothing. This guy is not possible in the first place because for some reason whoever typed this worksheet put a negative argument in there in the first place, and that can't happen, so nothing over here can be true. So I jumped the gun and started solving. None of that work was possible because this is impossible in the first place, since it had a negative argument. So that's no good there. Well, let's dive over to the second one. So, alright, does every term have a log with it? No. So let's condense and totally rewrite exponentially. So Mr. Exponents get to come up top, and because there's a subtract, we're going to do a divide, but we still need the log base too. I need a fraction bar. So this is going to be upstairs, and it's going to be x cubed. This is going to be downstairs, and it's going to be 5x quantity squared. And it's still going to equal 2. So all I have done is condense this guy. Then I'm going to rewrite exponentially. So I'm actually going to clean up this argument first. So this is really 25x squared because the 5x needs to get squared. And I'm going to rewrite the whole thing as log base 2 of, since there's 3 x's upstairs and 2 downstairs, we can just call this x over 25. So the x cubed over the x squared simplified a little bit. Now I'm going to rewrite it exponentially. The base is 2, the exponent is 2, and that's going to equal the argument. So base, this is back to the very first day of logarithms. When you had it in log form, rewrite it exponentially. Scratch that homeboy out and call him a 4. And now to solve for x, I'm going to multiply by 25, and x equals 100. Still got to go check it to see if we get a positive argument. If you put 100 back in here, that'll be positive, so that's nice. If you put 100 in here, that's a positive argument, so that's nice. So our solution is going to be 100. Who wrote this worksheet? What a bogus problem that was. Silly goose. All right, let us know if you have any questions. Have a good one.